Hello grade 12s. Welcome to grade 12 analytical geometry. Now the grade 12 analytical geometry is all about the equations of circles, but it does involve all of the grade 11 geometry that was discussed in the previous video as well. I always say to people, grade 12 analytical geometry becomes a lot more complicated than grade 10 or 11. And the only reason it becomes more complicated is because it now takes everything and it brings it in together in one spot, meaning we are now going to have to be working with circles, which means not only must we do the analytical geometry part of the circles, we must also remember the Euclidean geometry part of the circles. So you'll see in a lot of the videos I'm going to be talking about the Euclidean geometry circle theorems. Not all of them, luckily, but there are quite a few of them that become incredibly important here. Just apologies. For some reason, the document reader that I'm using is making this look like an oval. I promise you, when you see my scanned notes, it's pretty much a circle, but I do apologize for those of you who have to look at it and kind of flinch every single time and go, that's not a circle. It looks like a circle to me. Unfortunately, it's not going to look much like a circle to you. Okay, let's get started on the equation of a circle. By the way, the formula that we're going to deduce now is on the information sheet, but I don't like teaching people formulas unless I show them where it comes from. Luckily, this is not a complicated process to see where this formula comes from. It's actually very simple and straightforward. So when we find the equation of a circle, we have to remember a circle is defined as always being equidistant, so equal distance from a point. So you will always have a center to a circle. And when you go to the circumference of the circle, that's obviously going to be the radius. But the radius there is going to be equal to the radius over there, is going to be equal to the radius over there, is going to be equal to the radius anywhere. So if I go from the center of the circle to any point on the circumference, it's going to be the same. Now if I name these points, so I say this is my point, which is the center of the circle, and we're going to call that the point AB. So the x coordinate of the center of the circle is A, and the y coordinate of the center of the circle is B. Then this point over there is going to be a variable point, meaning it's any point on the circumference of the circle, and we'll call that the point xy. Then what you need to understand is you need to understand the following. The distance between the center and the circumference is always the same. And the distance between the center and the circumference is always equal to the radius. So what we're talking about here, we're talking about the distance formula. We're saying the distance is x2 minus x1 squared plus y2 minus y1 squared. But the distance between these points, the distance every single time between the center and the circumference, we call the radius. And then we can go and we can sub into that formula saying it is then going to be the distance between the variable point, which are all those little points. We call them variable points because any of these points, any of them, could be that point on the circumference, whereas the center of the circle is not a variable point, that's fixed. And the radius also not variable, that's fixed. But this point could be any of that billion points that's located on the circumference of the circle. So it's going to be x minus a squared plus y minus b squared. And if I square both sides, sorry, let me just put that bracket in. If I square both sides, I end up with this. And that, people, is on your formula sheet. Not exactly in that format, but on your formula sheet what they say, therefore, the equation of a circle with a center at a point AB and a radius of r units is equal to x minus a squared plus y minus b squared equal to r squared. And that is the formula on your formula sheet. That's the formula we're going to be using to find the equation of a circle. Okay, so let's start finding the equations of these circles. How to determine the equation of a circle? Well, number one, we have this formula x minus a squared plus y minus b squared is equal to r squared. And just remember, to remind you guys, AB has always got to be the center of the circle. Why? Because the center of the circle is fixed. It's fixed on the Cartesian plane. They put a dot in it, they put a pin in it, so we have to have a center point. Whereas x, y can be any of those billion little tiny points on the circumference of the circle. So when you have that xy, that's going to be any of the coordinates on the circumference of the circle. They also call it a point on the circle. Remember, that's any point on the circle. A lot of people confuse this. A lot of people seem to think the center of a circle is a point on a circle. It's not. If you look at the previous diagram that I drew, the circle actually doesn't touch the center. It doesn't go through the center at all. So please remember, the center is not the same as a point on the circumference. It's a fixed point. It's where you pin the circle to the Cartesian plane. Whereas a point on the circumference of the circle, so in other words, a point that the circle goes through, are any of these points over there. So there's lots of options there. And then r is the radius of the circle. And please remember that radius is specifically the distance between the center of the circle and the circumference. Right, so just to remind yourself, this is how the formula works. So if I have the center and the radius that are both given, so they give me the center of a circle, like in example 1a on page 254. The center is given as the point 2, 1. The radius is given as the point 2 square root of 3. I can then just sub very, very, very easily into that formula. Really easy. Please don't complicate it. So I will then just go and say it's x minus the x coordinate of the center, which is 2 squared, plus y minus the y coordinate of the center, which is 1 squared. And careful with this one, because remember, you have to use the radius squared, is equal to 2 squared, 3 squared. Now, by the way, you don't have to go and multiply out these brackets at all. They consider this to be the standard form. The only thing that you will have to do, however, is you are going to have to just go and square the radius. So you don't have to do the binomial squared. You can keep it like that. So x minus 2 squared plus y minus 1 squared is then equal to 2 squared, so 4 times 3, which is 12. So they consider that to be the standard form of a circle equation, and that's why you don't have to expand the brackets. You can just keep it like that. So that's the answer. That's the equation of that particular circle. Okay, next. If the center and a point on the circumference are given, we have to do a slightly different calculation. Now, if I refer back to this formula again, you'll notice we pretty much have three things going on here with every single circle. We have a point on the circumference, that's the point xy, or point that the circle goes through, so that's the point xy. We have the center of the circle, so that's the point AB, and we have the radius. So in this example, the first example we did, we have the center and we have the radius. In this example, they don't give us the radius, but they give us the center and they give us a point that the circle passes through. So this circle passing through the point -1, 1. And this is example 1b on page 254. So if I just write down the formula, just so you can see what's going to happen here. I don't have the radius, but I do have the center, which I can sub into A and B. And I do have a point that the circle passes through. And whenever I have a point that the circle passes through, you can substitute it into x and y. And what will that do? That will give me the distance squared. So that will give me the radius squared. Because remember, the distance between the center and a point on the circumference is the radius. So that's why I can just sub in there, and I can say center is going to be, okay, first the point on the circumference is -1 minus 3 squared, plus then 1 minus -5, so 1 plus 5 squared. And that is going to be equal to the radius squared. So this is going to be -4 squared, which is 16. This is going to be 6 squared, which is 36. That means the radius squared here is going to be equal to 52. And that is why I can then find the formula of the circle, or the equation of the circle, x minus 3 squared plus y plus 5, y minus -5, so y plus 5 squared, is then careful equal to 52. Please note, I haven't square rooted it. If I want to find the exact value of the radius, I will square root, and then I will work this one out. But for this one, they didn't ask me what the radius were. They asked me for the formula, so that's why I keep it like that. Okay, so very easy. If they give me the radius and the center, I can just sub it into the formula. Or if they give me the center and a point that the circle passes through, I can calculate the radius, and then again I've got the equation of the circle. Very easy. Right, now here's the trickiest part of the video. How to determine the center and the radius of the equation of the, how to determine the center and the radius if the equation of the circle is given. Do you go and you look at it and you go like, okay, why is this tricky? Initially, it's not tricky at all. So they give you the equation of this particular circle, and this is example 2a on page 255. They say this circle is the circle x minus 5 squared plus y plus 1 squared is 24. And the question they ask is they ask you, please find the center and find the radius of this particular circle. So the center is easy. It's my AB value. So A is what's in that bracket, but please remember you've got to change the sign. So it's x minus A, which means A is equal to 5. And it's y minus 1. Sorry, y minus b, so y minus 1, so the y coordinate of that center is -1. So that means 5 minus 1 is then the AB value, so it's the center of the circle. The radius, be careful, because please remember this is the radius squared. So if I want the radius, I first have to go the radius squared is 24, and here I will have to use those square root on both sides. Now normally my class knows that whenever I say square both sides, I always say please remember the plus minus. Now that is very important when you're solving quadratic equations and you use that square root on both sides. However, a radius is a distance. Because a radius is a distance, it will always be positive. So because it will always be positive, this is the only case where you don't have to put plus minus. It's always going to be positive. So the radius here is going to be equal to, and I'm going to put it in simplest third form because that's generally what they ask for. So it's 4 times 6, which means it's 2 square root 6. If you have forgotten how to do those simplest third forms, please remember your calculator will do it for you. So if you go the square root of 24, it gives you 2 square root 6. And unless they ask for you to round it off to 1 or 2 decimal places, you can generally leave it in simplest third form. Okay, so that was pretty easy. Now, I don't know if you were looking at the bottom of the page slightly and saying, huh? Okay. This specifically is also the equation of a circle. So this is example 2b on page 255. So they gave this to you and they say, this is the equation of a circle. So what happened here was somebody went and they didn't get the memo that I gave you earlier about the fact that we don't want to multiply out those binomials. So those brackets, the x minus a squared, the y minus b squared, we don't actually want to expand them. So somebody didn't get the memo and whoops, they expanded it. So instead of giving you the proper version, the standard version of the circle equation, they gave us this one. And they go, here it is. Now from this version, which is not the standard version, I cannot read off the information of the center of the circle or the radius of the circle at all. So in order to fix this, I need to have these binomial squares. I need to have these perfect squares. And this, people, is back to grade 11 again. And I did warn my class about it last year. I don't know if your teachers, the rest of the teachers warned you guys about it. But I told them last year, when we did completion of the square, I said to them, please, people, you're going to use completion of the square in analytical geometry in grade 12. Luckily, it's much less complicated than it was last year. Number one, it's because you're seeing it for a second time. And number two, also because these are very easy ones to do. So you just try and jog your memory on completion of the square. So in order to complete the square, you need to realize we need to put all of the x's in one spot together. So x squared and minus 8x will go over there. And I'm going to leave a space there to complete that square, because we're going to have to do completion of the square twice. We're going to have to do completion of the square for the x bracket, so that we can find the x coordinate of the center. We're going to have to do completion of the square for the y bracket. So I'm going to leave a little space there. Plus then, and we're going to collect all of these y variables, so y squared minus 2y, and I'm going to leave a little space there for completion of the square, is equal to, and that minus 20 will then go over here as positive 20. Now in order to complete the square, hopefully you still remember the formula from last year. you take this coefficient right there of x, and all you're going to do very simply, and this is the little line, half it, square it. No, this is not very mathematical, but this is what I always tell people. To complete the square, half this, square this. So minus 8 halved gives me negative 4. Half means divide by 2 or times by half. So negative 8 divided by 2 is negative 4. And once you have the negative 4, square it. And careful people, when I square a negative, it always becomes positive. So negative 4 squared is 16, so it's plus 16. So I complete the square by saying take the coefficient, half it, square it, and then add it. That is going to complete the square. So I'm going to do exactly the same thing there. This time I'll just do it properly and mathematically. First divide by 2, and then I'm going to square it. So half it, square it. Minus 2 divided by 2 is minus 1. But when I square that negative, it becomes plus 1. So again, that's how I complete the square here. Take the coefficient, half it, square it. That's how I complete the square there. Take the coefficient, half it, square it. Now hopefully you will realize that I've changed the left-hand side of the equation. I've changed the left-hand side by adding 16 and 1. So overall I've added 17 on the left-hand side. And please remember, in an equation, it's a scale. It needs to be balanced. So whatever I do on the left-hand side, I have to do on the right-hand side. So I add 17 to the right-hand side. Okay. Now comes the only little tricky part, which is writing those trinomials as binomials squared. Now, the good news here is, whatever value you got when you halved it over there before you squared it. So remember we said minus 8, half it gives me negative 4. Now please remember you have to square it to add the correct value here. Otherwise you're going to get the wrong value over here. So you can't just go and skip this step. You can't just go, oh, half it. No, you've got to do the half it, square it here to know exactly what needs to be added on both sides. But when you've got that half it value, which is negative 8 divided by 2, it's negative 4. That's what goes into this bracket. So it's x minus 4 squared. When you've got that half it value, so negative 2 divided by 2, it's negative 1. You've got that y minus 1 squared. And you can check, because obviously x squared, there you go, that times that double up, there you go, and that 1 squared gives me the 16. So I know that's correct. Same thing there. If I square this, y squared is y squared. That times 2 is negative 2y. That 1 squared is plus 1. And therefore, that's the equation of that circle, the standard version of that circle. Now it's easy, just like the previous one. The center of the circle is 4, 1. So it's 4, 1. And then the radius, careful, the radius squared is 37, which means the radius is equal to the square root of 37. And that should be the simplest third form, because 37 is a prime number. If I'm correct, let's just double check. Yes, so that's just going to be square root of 37. So I did put quite a few of these ones in the homework because you do need to practice them. You please need to know how to convert from the non-standard form of a circle equation into the standard form by doing that quick completion of the square, which hopefully wasn't too tricky. Okay, now we're going to do example 3 here on page 255. So in example 3 on page 255 it says, determine the equations, now note, plural, equations of circles of radius 5, which cuts the x-axis at the point 10 and at the point 70. So what they're saying we have two possible circles that can go through the point 17 that has a radius of 5. Now the first thing you need to notice is the distance between these 2 points is 6. So because the distance between these 2 points is 6, there's no way, because if I go half-half, it's going to be 3 units, 3 units. So there's no way that the radius can go through here. That can't be the radius, because then the radius is going to be 3, because the diameter is 6. So that means to get to that distance, that radius of 5, we have to understand the center of the circle needs to be slightly higher up. So that this is 5, this is 5, it's not very accurate, but you get the idea, hopefully. This is 5, that is going to be the radii, so this is the center of the circle. So it means your circle should go, I'm not very good at drawing circles, I have to admit. Your circle should go somewhere over there. So I get that radius of 5, radius of 5. Okay, but hopefully you guys will also realize that this circle could go down. So that means the center of the circle could be here in the first quadrant, or the center of the circle could be somewhere over there. Because this could also be the center of the circle, then this could be 5 units, this could be 5 units. That means your circle could go somewhere around here. These are very badly drawn. Sorry. I really can't draw circles. I can draw straight lines, but I honestly can't draw circles. So that's pretty much what you're looking at. Now you're trying to figure out the equation of these two circles. And in order to figure out the equation of these two circles, hopefully you guys will notice that this right there, if I drop a line down over here, this is going to be perpendicular right there. And because this is an isosceles triangle, it's going to mean that if I drop the line down perpendicular, this goes halfway, this goes halfway. And because it goes half-half, you will then already know the one thing is that the center of the circle, the x-coordinate, is going to be, that's 1, 2, 3, 4. See, 4, 5, 6, 7. It's going to be halfway. I don't know what the y-coordinate is. And there as well, I've got that x-coordinate of 4, and I don't currently know what the y-coordinate is. But here's the beauty of it. The beauty of it is, I now know that the distance from this point to this point, and this point is the point 70, is equal to 5, because that's the radius. So what can we do now? We can actually use the distance formula. So we can say in the distance formula, 4 minus 7 squared plus y minus 0 squared, and we're going to put a square root over that, is equal to the distance, which in this case is equal to 5. Got it? So I can then go and I can actually work out that y-coordinate, which means I will then know what the center of the circle is over here. So I can do that by saying, by the way, you can now square both sides. So you can then say 4 minus 7 is minus 3 squared, which is 9, plus y squared. And since I've squared both sides, this is going to be 25. So y squared is then equal to 25 minus 9, which is 16. So y is equal to, and careful, this time, when you use the square root, you have to use the plus minus. I said previously you didn't have to because radius is always positive, but in this case I'm not working out the radius, I'm working out the y-coordinate. And y and x coordinates can be positive or negative, as you can see from the diagram. We need a negative y value, and we need a positive y value. So this is going to be plus or minus 4. So now, I know what the center of the circle is. I know the center of the circle is the point 4, positive 4, or it's the point 4, negative 4. So I can then go and I can write the equations of the two circles. The first circle is going to be x minus 4 squared plus y minus 4 squared, and that's going to be equal to, careful, my radius squared. Please don't tell me it's equal to 5. It's not equal to 5, it's 5 squared, so it's 25. Or the second circle is the one over here that's got the center point 4, negative 4. So that's going to be x minus 4 squared plus y minus 4, so it's y plus 4 squared, and that radius is 5, so radius squared is still 25. So this is something you're also going to see, construction. Construction is super important. They actually want you to do constructions. So if they go and they draw this diagram and they give you the circle, draw those constructions, and otherwise most of you would never have noticed that the x-coordinate is 4, because the x-coordinate has to be halfway between those 2 points. And also, a lot of you would never have noticed that I've got a line there, the radius, where I've got the distance, and I've got the x-coordinate, so I only need the y-coordinate. So, as I said, try and make a solution where at first there doesn't seem to be a solution. We are going to be doing more and more difficult questions. Okay, but that for now is just finding the equation of a circle if certain information is given. Thank you very much for listening.